Which is which, so...
Yeah, that's right. So, and quite frankly, as always, I'm the most boring person in the room, so the best thing for me to do is get off quickly. I'm just going to say thanks so much, guys, for coming along and sharing your story with us. It's going to be an exciting one. I don't know how many of you have had a chance to take a look at Edmund Hillary Fellowship and what they're up to in their big picture thing, and the particular thing they're going to talk to us about today, but it's all very exciting for New Zealand as a whole, and Queenstown in particular. I will recruit your support throughout the evening and persuading them to move here so that New Zealand space industry can be based out of Queenstown, as it should be. But apart from that, I will just say thanks very much to QT Hotel, who have been supporting this evening. So that's the obligatory done, and now the sincere bit. No, it's been great. So they've been really helpful to us. And it's quite good to take a look at sort of the new facility they're putting together here, so interesting stuff. But without further ado, I will revert to cliche and exit the stage. Then thank you, Ellen and Eric.
No, well, thank you so much as well. I think I'll return the favor. AJ was instrumental in getting this organized. I mean, it was very short time frame when we told him, well, we were going on this tour to promote the New Zealand Space Challenge, and we're going to Queenstown, and basically he just hopped on and like managed to make this all possible. So we're really, really grateful. And at the same time as well, thank you to all of you who are coming here, sacrificing your Friday night, going partying and doing other probably great things in Queenstown to sit here and be geeky with us to talk about space. So for sure, yeah, so thank you so much. So maybe just to kind of like give you a little bit of an understanding of our main theme here is the New Zealand Challenge, but I wanted to take you back into like the big picture of why we're here, why space, why New Zealand, what's your kind of like your role, and what's New Zealand's role kind of like for the future, and then why that kind of dovetails into the New Zealand Space Challenge that we kind of that initiated. So. Just to start off, as AJ was like talking about, we're here on a 3-year global impact visa because of the Edmund Hillary Fellowship Program. Who here has actually heard of the Edmund Hillary Fellowship? Oh, great. So it's a new program by the government to bring in to New Zealand entrepreneurs and investors to come to New Zealand to work on something that is highly impactful for New Zealand but has a global scale. But it's also not just for foreigners, it also has a Kiwi component, so you can be a Kiwi and apply to the Edmund Hillary Fellowship. And the thing is, for 3 years, they want to have 300 fellows over that 3 years, and they're basically taking applications every 6 months. So we're on the first cohort. We applied, it was about 300 applicants, and we got downsized to like 28, and so we started last October. And so we're here in New Zealand. We're really grateful. So the other thing, as well as maybe we'll just give you a little bit of our backgrounds as well. So we applied. Eric and I come from California, basically mainly in the Silicon Valley area. But originally, I'm actually from the Philippines, so I still have U.S. and Filipino citizenship. And my passion has always been space. So as a kid, like growing up with Star Wars and Star Trek, you know, that's sort of like at least my personal motivation for going on to this like a career in space. So if I sort of summarize what I've done over the past 3 decades, I'm pretty old, is that I've worked on essentially ecosystems on tech and space. So International Space University, which is a non-traditional university for space, Singularity University as well. I've been with them since the very beginning. I've worked on several space startup companies as well. So Space Adventures is one. It's the first company that has actually sent tourists to space as paying passengers to the International Space Station. We brokered the deal through the Russians to do that. And then there's also basically Odyssey Moon that became Moon Express, and what they're vying for is a FedEx basically system to go from the moon and back. And Moon Express is about to fly on Rocket Lab in the next few months. Unfortunately, they didn't make it for the Lunar Google Express. So there was a prize for like $30 million for who's the first private company to go up in space and go to the moon. But that sort of expired, and unfortunately nobody won. And then the last thing is that I also wrote a history book on the private space flight, the human space flight history over kind of like since the 1960s and where it's going. And then Eric, you want to talk about your...
Oh, okay. Yeah.
I talk a lot.
All right. Yeah, I'm Eric Dahlstrom. I started in physics and gravity theory, black holes, and then astronomy, mapping the galaxy. And then I went into engineering and space station design for 8 years at NASA Langley, and teaching at International Space University. Actually, this is how Emily and I met. We met here, and fell in love there, and got married there. So, and then, and most recently in California, I've been working with startup companies like Moon Express and others. Yeah, that's all.
And so I said my passion was space. It's my first passion. The second passion is like I'm actually passionate about impact. So I think I had the privilege of being able to actually experience, living in a developing world where I grew up and I didn't leave the Philippines until like after my undergrad. My background is physics and space science, and I did my undergrad in physics there. But then also being able to, go to the U.S. and Europe, and then be in Silicon Valley where you get to play with, the coolest tech and the biggest and newest innovation. I wanted to kind of like make sure that gap doesn't become bigger and bigger, because that's what's happening today. And so for me, I really want to make sure that the rest of the world is brought together to create this global economy, global space economy that we hope to happen in the future. And so that's sort of, that's like why our moonshot for actually being in the Edmund Hillary Fellowship is to democratize space. And when we talk about democratization of space, it's for everyone. And as I mentioned, we want to level the playing field where we want to make sure that it's not only the US or China or Russia will be the ones to actually bring us to space. We want the rest of the world to be part of that ecosystem and economy, which is why we're kind of like here in New Zealand. And the way that we thought about doing that is that we created SpaceBase. We actually incorporated in New Zealand at the end of November. It's a social enterprise. We want to create this ecosystem within New Zealand to start an industry. And there's kind of like many ways of doing that. So there's two of us here. We have another co-founder that's still in California. He's the tech guy and helping us with some of the components of this enterprise. So how do you actually create a space ecosystem when there is none? So we're thinking, essentially there's a holistic way of doing this, and there's a roadmap where you think about education and training and creating the capability and the capacity kind of within a community to start with that. And then from that, you get entrepreneurs and like sort of ideas and projects, and so that you can get, you can create startups. And then when you have the startups, how do you help them get the tools and the training and the incubation and the sort of like the acceleration to make those businesses thrive? And then of course, how do you get them to get funded as well? So that's sort of like what we're looking at. As a short-term goal, the two things that we're working on right now are like, the first one is like the space directory. So right now, if you go to spacebase.co, it's essentially a directory where we're trying to find the who's who in New Zealand who is working in space. So individuals and organizations. Most people would say, well, there's only one company in New Zealand that's that's really a space company, it's Rocket Lab. But I mean, that's a really narrow definition of what it is. And when we were looking at organizations, there's actually about 70 organizations that have, from one way or another, they're not launchers or spacecraft developers, but all along that supply chain, there's a lot of companies that are already working kind of like on the space industry. So the second part is that how do you create that community? And for us, one of the easiest way to do that is to use incentive prices to kind of catalyze an industry. Which is why we now have this first New Zealand Space Challenge. And so challenges are also not new. They've been around for ages. There's been a lot of them that has been happening even today. So NASA, for example, does the International Space Apps that we've judged in other places. There's also another one that's happening during Tech Week. It's called Act in Space, and this is being sort of produced by the Center for Space Science and Technology down in Alexandra. But the culmination of it is going to be in Tech Week in Christchurch, just like the New Zealand Space Challenge. So, going back to the question of why space in in New Zealand, but I think what I want to first talk about is why this is even possible today. So, in terms of accelerating technologies or exponential technologies, these are, within the past 5 or 10 years, this is being more apparent as we see technology develop and accelerate really fast. And this is being borne by, as you may know, Moore's Law, which every 18 months or 2 years, the price performance of computing has actually doubled. And so the acceleration, any technology that is actually computer-based will also accelerate the same way. And which is why robotics, biotech, nanotech, they're also accelerating exponentially in the same way. And this has started democratizing space. And so as a case in point, we take for granted our cell phones today. But if you see here, one cell phone is about 120 million times more powerful than all the computers combined that send man on the moon. So basically the whole Apollo program, all of the computers combined, is your cell phone in your pocket today. So the difference between between then and now is just pretty powerful to see the development. So here's another example. Today, we get our weather reports from big weather satellites up there that take millions of dollars to launch, and then you also need big ground stations to actually capture that data. But again, you go online, you buy a software-defined radio receiver now for $20, and this one we bought here in New Zealand. You can replicate that weather image by just basically downloading an unencrypted data from a satellite that's unencrypted today with your laptop. So again, this is the reason why we were saying that technology has been democratized. It's in the hands of anybody who just has a Wi-Fi and a laptop and knows how to actually code. Another example is, Endurosat is a Bulgarian company, and actually it was founded by one of our students in Singularity University. He basically, over the years, he slowly built up their capability on the software side and on the hardware side, which so much so now that you can go online today on Endurosat website, the components of a CubeSat, CubeSat satellite, you can basically pick and choose the components, and within 5 days, they can guarantee to deliver that already assembled CubeSat. and this is in Bulgaria, so it's not in Silicon Valley, it's not in the US, but these are components that they've already kind of like managed to manufacture. So again, exponential technologies widen the horizons for the different kinds of like technologies and market opportunities because of this. And these are sort of like some of the examples here. So one thing to, I guess what I'm like stressing is that when we talk about space, we're not just talking about rockets and launchers. It's all of these things as well. Another example is Made in Space. So these are also our students back in 2010 in Singularity. Their moonshot is they want to basically manufacture big structures in space. So if you think of the 1960s like colonies of O'Neill and so forth, those are the kind of like things that they wanted to do. But they also knew how to connect that big goal to their how do you start. So they latched on to 3D printing, which is an up-and-coming technology like about 7 years ago. And what they did was, so how can we create a 3D printer that can function in space or function in zero gravity? Because like today, normally when something breaks in the ISS, like even a tool or something, or you misplace your tool, the next time you can get that replaced is when another launch goes up and you get it. But either way, you know, you're stuck if there's nothing. But around 2014, after all of the testing, and they managed to get their 3D printers working, there's now 2 3D printers in space up in the ISS. And so this, for example, this picture here, one of the astronauts misplaced his wrench, didn't really know where it was, and it was a critical thing. So what they did was they emailed the CAD file to the station, and then overnight it got printed, and the astronaut didn't even know that they were actually going to print the wrench. And when he woke up, now he has a wrench, because now you got an actual 3D printer up there. And where does this all go? It goes to their moonshot, or their long-term goal of wanting to print huge structures in space. And so actually now, they haven't built it yet, but they now have they were commissioned by NASA with, and I don't remember how many millions of dollars.
25
I think
or
it's
something.
$25 million to basically test this technology to actually create those structures, using potentially also materials that we don't have to launch from space. So, with all of these like exponential technologies that are happening, even now the big players as well, you know, just like SpaceX and Jeff Bezos from Amazon, or even the traditional guys like Lockheed Martin and Boeing, are now looking at exponential technologies to help them create these huge big missions. So I don't know if you've noticed recently, I mean, even with Rocket Lab and SpaceX's like recent launches, there's now a proliferation of you know, news about, you know, going to the moon, going back to the moon, going to Mars, and like mining asteroids and so forth. If you think about that, like maybe 10, 15 years ago, yeah, those are pipe dreams, like there's like science fiction. But actually today we have the technology already to do those things, and now even the big players, meaning the guys who actually have the money to invest and make this happen, are now joining the bandwagon to make it happen. But again, oh, I just put Elon's Tesla up there because it was such a freakingly cool thing that happened last week. But again, even with this, there's still billions of dollars, like the big missions that people would say, well, okay, what does New Zealand got to do with the big missions? It's still too expensive to be part of it. But again, in terms of looking at the big picture, these are the big missions here with SpaceX, Blue Origin, and like some of the ULA consortiums of Boeings and Lockheeds. And then with the Rocket Lab, which is in a sweet spot here, Rocket Lab right now actually is in a class by itself in terms of the type or the amount of payload that it can launch up. Like it used to be, you always have like these big rockets that you have to wait until you fill up the rocket to actually go. And it might be going where you don't want it to go. But today, because you now have a smaller class of rockets that can put up smaller payloads, then they can actually go up more frequently. So they're in a sweet spot there, but all of these, from life support systems to manufacturing food in space to like habitats and so forth, those are essentially new space markets that are up for grabs. And I think that this is one of the things that we think that New Zealand could potentially look at their traditional industries. So, like for example, what I was talking about in terms of food production, which New Zealand is like really great at agriculture, tech, and all that. So that's something that you could connect the dots to. Well, if you're a food specialist, well, we will need that for future space missions in the future. So there's that link. The other thing as well is that all of these big guys are only looking at, as I mentioned, they're only looking at the launch technology. So they're making all of these big rockets to get us to there, from like A to B. But everything else, from the life support system to, again, the food, the habitation, when they get there, those are still, nobody's working on them at the moment. So again, they're definitely big opportunities. So one kind of like analogy is that, in terms of like Antarctica today, New Zealand is, a specialist in Antarctic research support and logistics. I mean, it's known worldwide that that's a specialization, of which essentially what you're doing is that you're supporting people going to extreme environments, which is very much in analogy to, for the future, there's that element of, there's a potential for New Zealand to also be maybe the kind of like the specialist for logistics support or all the things that we normally kind of like do with Antarctica can be replicated in the same way with space. So the last thing I wanted to talk about before I hand it over to Eric is that also the question is, okay, we know that now that space is something that potentially there's a big opportunity, but then at the same time, why New Zealand? Like, why are we here as opposed to, like, say, we would have gone to Luxembourg or we would have gone to Singapore. And for us, there's like certain elements that you need to actually have a sustainable industry or space industry. And New Zealand actually ticks a lot of those boxes. I mean, if you actually put it in a grid, I always like say and look at like some of the countries that are interested in space. New Zealand ticks most of the boxes than others. And why is that? So for one, we actually think that you got a progressive government that can at least move faster than others to create those policies and regulations to make businesses thrive in space. So we just happened to Rocket Lab. I think Rocket Lab actually pushed the government to be able to make sure that launches are possible. So that's one. The other thing is that the isolation of New Zealand is actually its benefit. There's nothing in the east and there's nothing in the south, which means that there's more frequency for launches because the air traffic around here is so much more less than if you were like launching from Florida or you were launching from Kourou for the European Space Agency, because it's like it's where the traffic is And so that's one. The other thing is because also it's very isolated, the launch angles are more for launching satellites. The other thing that we noticed too is that there's already an existing education and tech community here in New Zealand. And it's pretty high there, and also an entrepreneurial community. So that's one of the things that's also very important to look at. And then maybe the thing that's sort of like obvious now with Rocket Labs is that it now has the launch infrastructure and capability to actually launch rockets. So today, New Zealand now is the 11th country that can actually launch something in space, like from all of the countries around the world, and that puts New Zealand sort of like in another caliber or level of being a spacefaring nation than others. And then I think for me also, I think it's the culture in New Zealand of being explorers that I think maybe even trumps all of the others. Where we always think that with the Maoris and the Polynesians coming to New Zealand, being daring enough to actually explore new worlds. And then today, where you're supporting Antarctica, it's the same way, where you're also supporting Antarctic explorers to go into extreme environments. So then what's next? And then what's next is like supporting or being space explorers. So Eric,